Good evening, ladies and gentlemen. Hope I'm audible.
Yes.
Gopkumar, I'm audible? Okay?
Yeah, you are
All is
audible.
okay? Okay,
Yeah.
good evening, everyone. Welcome to the third part of fire in building. Fire due to short circuit, fire due to electrical safety. So, the very important subject that we are covering today, and usually we do on Saturday at 11 o'clock. This time we thought, let us try on a weekend, that is Friday at 5 o'clock, and see how the response is. I think majority of them love to have it on Saturday, which is more, free and convenient. We do have an engagement tomorrow, so hence it was done doing on Friday. So next webinar, we'll try and do it on Saturday at 11 o'clock as usual. So today's webinar is the initiative of Cape Electric, which is owned by Mr. Kumar. So, ladies and gentlemen, since last week, we have seen a lot of fire happening in Mumbai and elsewhere. The catchword in all these cases was short circuit, short circuit, short circuit. As you switch on the TV, if there's a fire, the term is used, short circuit is quite common. But short circuits are not an act of God. So we always say, it's a fate. It's our fate, or it's a fate of the occupant that they have a fire. So we always leave it to others. We always, pray to God that, save me from fire. It's a natural act. It's not a natural act. It's a man-made event involving carelessness, negligence, and monetary shortcuts. Monetary shortcuts is something very important that everybody should know, and blatant flouting of rules and sheer recklessness. These are the cause of this incident that's happening around India. The truth is that there is no need for a single short circuit to occur. And when there is one, investigator must examine whether a charge of probable homicides without actual intent can be charged on the person responsible. Is there a dilution of duty of care? Many times that the society president or the developer is always taken to task, and he goes behind the bar for 6 months. It's a non-bailable offense if there's a fire in a building, and which is caused due to negligence. And this is today's, Hindustan Times, very interesting one. The BMC says the many fire that happens in Mumbai and other places is 70% is due to short circuit. Okay, and this is a 60-story building, Avigna Park in Mumbai. And very interesting, the report says the officials from Mumbai Fire Brigade, the case of fire at one Avigna Park, the fire started in a video doorbell. This major fire which occurred started on video doorbell due to short circuit and later spread to other areas. So still they're examining. As they said, it's a 70% due to. So Ashwini Bide, who's the Deputy Commissioner of BMC, there is no mechanism for having a societies to conduct electrical audit. So mind the word, there is no mechanism for having societies to conduct electrical audit. So they are in dialogue with the state government to come out with some mechanism where every year they review the fire safety in hospitals, malls, and large societies. So it's simple. Why constant building fire is reported due to short circuit? It is always overload, and when too much of current flows causing heat buildup or wiring to break down. The majority of the fire accident all over India, when we look, 55% of that is caused due to faulty electrical equipment or overloading the circuit. Some of the facts that hope everybody knows, We lose almost 26,000 people in a year. Between 24 to 26,000 people die due to fire accident. And 38,000 crores worth properties are lost in a year due to fire accident, which is quite huge, 38,000 crore. And India ranked number 5 in the highest fire accidents in a year. And fire department received 608 fire calls every day. These are some of the facts. These are the reason that we always come with this knowledge series, try and educate people, try and impart the importance of standards and code that we need to follow. And as a consumer or an end user, what do you need to ask the developer or an architect, how well they've designed the whole building. So the necessary to educate is to ask question. How many of us do really ask whether how safe my building is and what is the load that I can put it on my electrical circuit? So the facts are important to know and important to question. So I am Dominic, ladies and gentlemen, and I've been in this fire industry almost 34 years, founder of Fire and Security of India, now Focus, which is Forum of Critical Utility Services, bringing all MEP services together to give comfort level to the user of the building. So we need to integrate, all our services need to integrate. And there has to be one platform which you can tell how safe my building is, how electrical circuits are safe, what is the load of the current in my building. So these informations has to be brought in only if these are integrated. So Forum of Critical Utility Services, the society of all the professionals in the MEP field to come together. So I've been in this field, so education, awareness is a continuous process. So yesterday we had a wonderful webinar on passive fire. How do you contain the fire? So we had a very good turnout, and today is our third part on electrical circuit. Today, as I said, Cape Electrical is continuously, supporting these electrical safety webinar. They have started in 1996. Cape are the first and front runner various technologies products in India, be lighting protection, be electrical insulation material. More, Mr. Gopakumar will talk about CAPE, and today's speaker, the well-known face in this subject, and is there everywhere. Wherever there's electrical safety subject, Gopakumar is the face there. And wonderful to have him today to speak about electrical short circuit. What is the reason? Why it's happening? He has more than 27 years of experience in electrical safety, lighting protection, EMI and EMC of electrical installation. He has conducted more than 100 site studies and case studies on failure of electronic equipment and presented papers of more than 1,000 seminars and training programs. He also published articles about safety in various magazines and published the book, The Missing Link. So this is our fifth or sixth by Gopakumar. I get a lot of emails, Gopakumar, asking where can I buy this book called Missing Link. I think you should come with an answer today that where will people can access to this book, from where they can get. I think it's time that you must, either second edition, third edition, you must come out and give this book to everyone. So whatever it is, you must give the very important book that you have published. And I would welcome Gopakumar to take over and enlighten the audience today. Thank you very much and welcome to you, sir.
Thank you very much, Mr. Dominic. You have to allow me to share my screen.
Yes, of course. Yeah.
Yes. So for the convenience, let me switch off my mic, switch off my camera. Sometime, it will affect the bandwidth. At the moment, I think we have more than 160 participants at the starting of the program. Having more than 150, 160 participants is an indication that today also probably we may cross 250. Anyway, good afternoon, ladies and gentlemen. I have switched off my camera because sometime it may eat up the bandwidth. To introduce myself, most of you know me very well. I'm a member in the BIS, some of the technical committees of ETD 20. Actually, today, two more participants, attendees from the same committee, Mr. Hemant Sali and Mr. Goswami. I could see them on the list of participants. So we are very much actively involved into the drafting of the National Electrical Code at the moment. I'm also a member in the IEC TC64, which is the basic electrical safety, low voltage electrical safety and protection against electric shock, the global standard, then TC81 lightning protection standard, and the SC37A SPDs. I'm working in some of the working groups of these committees. So today, actually, during the first and the second program, we discussed some of the issues. Today, I would like to take it up to a further in a different to a different level, and I would like to explain what the other countries are trying to do. Basically, this information, what developed countries are trying to do, is from my colleagues, those who are working with the IEC technical committees from other nations, because whenever there is a meeting, we used to discuss about what they do in their country to achieve. And most of the time, most of the engineers involved in the electrical safety, they are worried about the fire accidents, especially fire due to short circuit accidents happening in India. First, I would like to start with a statement. All of us must understand that there is no shortcut for achieving electrical safety. Why I made this statement is, a lot of engineers used to ask, can you suggest me some product which will solve all my problem? Can you make a black box and give to me so that my problems are solved? Can you make a magic box which will eat away all the the dirty problems which I am getting from the electricity supplier side? So my magic box must have Internet of Things. It must send me an SMS in case of a problem. It has to call back to me in case of a problem, and this should give a very, very clean output so that all my electrical installation is safe. So there are propagandas happening in the market saying that such magic devices can protect the whole thing, which is absolutely a big mistake. Magic devices and devices which claims to protect from overcurrent, short circuit, earth fault, surges, shock, fire, and all the known electrical safety faults. Number one, this is not practically possible. And number two, it's illegal. Why it's illegal? Because in order to have a good electrical installation, we are supposed to follow the rules and regulations. Why this is not practical? Of course, this is not practical because the engineer should understand the methods to handle overcurrent, short circuit, earth fault, surges, shocks, overvoltage, fire, and all these things. It's not about one problem. It's a combination of a lot of problems. And with one magic box, you cannot solve all these problems. And I presume that this magic box very soon will start creating problem, which will be an additional headache for people. So don't follow such things. Strictly follow the regulations and the rules and the code of practices. For example, Regulation 12 of the Central Electricity Authority, CEA regulation, says you should follow the code of practices for wiring or the installation and follow the Indian standards. The products used must follow the Indian standards, and the electrical wiring should follow the code of practice. This is the straightforward method. Follow the rules and regulations. Don't go with the shortcuts, because shortcuts can never help you. One such shortcut device is becoming a real headache nowadays. I'm getting a lot of phone calls and asking about what is this digital grounding device. Digital grounding is, it's a plastic box or probably a metal box, but it has got a big bus bar, as you can see here. And the manufacturer claims that you connect all your devices to bus bar, your problems with respect to earthing, your problems with respect to earth electrode resistance, neutral to earth voltage, surges, lightning, reverse lightning, all these problems are solved. Sometimes the words which they use, the manufacturer use itself, are some kind of new words in electrical engineering, which I am never heard of. So basically, this is really a problematic product. If you are using such kind of a product, very soon you will be in trouble. We have experienced in some of the industrial premises, large corporate companies, in order to avoid the neutral to earth voltage, this device is used. And what they do is, inside this device, they simply short neutral and earth together, which is a violation of the rule. Minimum insulation resistance between a current carrying conductor and the earth or the protective conductor inside an electrical installation is 1 meg ohm. Such devices are violating the rules. Neutral circulating current will flow through earth conductor, which will create problems of fire, shock hazard, unnecessary arkings, and finally failure of electronics. So such devices I would recommend, please don't use. It's a violation of electrical safety rule. In the first day, I also explained about the regulations 14, 15, and 16, which is from the CEA regulation, which talks about earthed conductor and earthed neutral conductor. Why I'm repeating this is there were a lot of questions in the last week. Plus, I was getting a lot of emails from engineers working in the utility companies asking how to interpret this particular point. So, in order to interpret, my request is we should start reading the CEA regulation 2010, then also read the IE rule 1956, then also go back to the 1937 electricity rule 1937, and we have to little bit read the regulations of the British during 1940s or 1950s. Then we will be able to find out the actual definition and the whole history of this. Earthed conductor is a TNS system. The fifth conductor in the distribution is the earthed conductor. Regulation 14, 15, and 16 says it is the responsibility of the utility company to provide earthed conductor, means TNS, or earthed neutral conductor, which is a TNCS network. In a TNCS network, the provision of making the earthed terminal, it's not an earth terminal, earthed terminal. Earthed terminal means a terminal here where I'm moving the cursor, a terminal which is connected to the neutral of the source. So for this whole power supply, earth is the point at which current carrying one of the live conductor is connected to earth. So this is the earth for the whole power supply. The earth terminal at the consumer premise is connected back to the neutral of the source. So this earth terminal is called as earthed terminal. It's regulation 14, 15, and 16. Request or demand for earthed terminal at the consumer premise by the electricity supplier. This is very, very important because you have a very low fault loop impedance path. There is a fault return path, metallic fault return path. In case of TNS, there is a direct path. In case of a TNCS, there is a link. So as a result of the direct metallic fault return path, the fault current goes back very quickly to the source. Enough fault current goes and your cutout, the fuse will disconnect the supply. Similarly, regulation 41 also talks about the earthing of the neutral conductor at the distribution. So I am showing some of the regulations here. Similarly, the IS 732 figure 61 explains how to make the distribution board in a consumer premise in case of a TNCS system. This picture is actually followed worldwide. Whatever the picture which I am showing, the three methods of making the electricity distribution board or the mains incoming DB for a consumer premise. This picture is from the IEC 60364 part 554. So basically globally, this is what is followed. But as I said in my first presentation, what is happening is you can see here in the where I'm moving the cursor, the earthed conductor is missing in our distribution. The electricity supplier is not providing any earthed conductor. As a result, the link between the neutral and earth is also missing in a TNCS network. So basically, the network becomes a TT network. In a TT network, you require a 30 milliampere RCD at the origin of installation, and you will have additional other problems as well. Whereas if you look at a medium size industry where they have, well, let us say 50, 60 kilowatt of connected load, a low voltage LT supply, working with a 30 milliampere RCD at the origin of installation probably may not work because of inherent leakage current of the devices. So these violations, actually, these are some of the reason for accidents at the consumer premise. Basically, there is a fault. You can imagine the consumer is having some kind of problem. There is a fault and the protective device is supposed to trip. It is the responsibility of the power supplier, energy supplier to ensure that the consumer premise is protected. Of course, the consumer also have certain responsibilities, but it doesn't mean that the responsibility is only with the consumer, but the supplier is also having a responsibility. And that is the purpose of making the regulations. All these regulations are violated. 14, 15, 16, very, very important. I would say, I would repeat that ideally these violations shall be treated as a criminal offense by the management of the supply company. So why I put as management of the supply company is most of the time the last fellow, the last person who goes for inspection, maybe the lineman or the smallest employee is he is made the victim of such failures of compliance, and they are put into trouble. Actually, in my word, this is the responsibility of the management. In order to achieve, the safety, electrical system which is called a system earthing, are classified into earthed system and unearthed system. It is in the technical terms, it is called as a TNC system, TNS system, TNCS system, TT system, and there is one more IT, which is used for special application. IT is an unearthed system, which can be used for a specific location in order to achieve safety and continuity of the supply. Especially the earthed system called as a TN or TT system, supply must be disconnected to achieve safety. Whereas in case of an IT system, supply can be continued to IT system, supply can continue until the first fault, during the first fault. The biggest misinterpretation happening in India is, I always call it as a joke, 2 for neutral, 2 for body. There is nothing called 2 for neutral, 2 for body. It is a totally big mistake, totally wrong. You should not follow this particular concept. You will invite a problem. Similarly, the system like clean earth means connecting the earthing of all the electronic items together, connecting it to an earth electrode in soil, power items connecting separately to an earth electrode in soil, lightning protection separate is also a big mistake. Please don't follow it. Similarly, separate earthing, but everything under soil interconnected together as a grid or as a ring. This is also a big mistake. Please don't follow it. This is not what is told in the standard. What is the correct way of earthing of a generator? You can see here the picture 38 to 41 of IS 3043. The DG, the body and the alternator, both bodies are interconnected together to an earth electrode, not to an earth electrode, sorry, to a bus bar, an earth bus bar. Neutral also connected to a bus bar. The incoming EB supply, earthing TNCS is also connected to the bus bar. The load side earthing is also connected to the earth bus bar. So this is the correct way of earthing. This means different metallic exposed and extraneous conductive parts in your building must have interconnection, not under the soil, but above the soil, a physical connection. So this is the correct way of earthing. Now, the regulation. This also last program I explained the regulation chapter 5, regulation 33 and 30 talks about testing of an electrical installation by the supplier. Of course, this is applicable for the supplier, energy supplier. Supplier should test before connecting. He should test and ensure that the here you can see 1 mega ohm, the insulation resistance between live parts and the earth or the protective conductor must be minimum 1 meg ohm. Somebody asked a question just before on the chat box, which I just in the Q&A, which I just answered. While testing, the gentleman has got about 2,150 mega ohm. Whether this is sufficient or not? Yes, of course, more than 1 mega ohm is accepted. Now, periodic inspection by the utility every 5 years is also recommended in the regulation. Of course, these are also, not followed properly. If these regulations are followed properly, lot of accidents can be stopped because the mistakes well in advance. Now, a lot of utilities. This is a little bit new. What I'm going to talk is a little bit new because last 1 week or last 2 weeks, I have got a lot of phone calls and emails regarding the what a utility should do in order to ensure safety of the consumer premise. And most of the time, a common subject which I am fighting, this is what I'm trying to explain to you. The methods followed by the utility or the industries. Example for an application of a transformer, 11 kV by 400 volt transformer. The people wanted to make a test. They believe that making the soil resistivity test, earth electrode resistance test, plus touch and step voltage, riser integrity, gravel resistivity, and a long list of tests. A lot of engineers are asking us or me to support them to make these tests like step voltage, riser integrity, gravel resistivity, and all those things. And they wanted to do the test as per IEEE 80, IEEE 81, BS 7671, BS 7430, and all. Unfortunately, only a little bit about the Indian standards are requested for. I don't know why our engineers, Indian engineers, always wanted to go behind the American and the British standard in order to test an Indian installation. These actually, the Indian standards are much more clearer and much more better. I would like to explain a small example. In America, the electricity distribution to houses are HVDS, high voltage distribution system. What does it mean is, on the right side, you can see I have put a transformer with a 20 kV input supply and 120 or 240, 120 phase to neutral and 240 phase to phase supply to the consumer premise. And the example, a pole top transformer. Basically, the electricity distribution is happening at 20 kV, and every house or probably a group of houses have got a transformer, and the transformer is generally a very small transformer which is connected very closer to the load. As a result, the voltage drop at the consumer premise is minimized to a low level. And these 20 kV, it actually starts from a substation. And this substation, the primary voltage is either 66 kV or even higher, sometime 132 kV bar 20 kV. So according to the American system or the system in USA, what they do is this substation means the primary voltage is either 132 kV or 66 kV. Secondary voltage is 20 kV. This substation, they make the touch and the step potential reduction measures as per IEEE 80. This is a very good system because the definition is very clear. They know what a substation looks like and they know their system and they do the best. The touch and step voltages are reduced based on IEEE 80. And now the problem which we face is our system is little bit different than their system. I'm sorry, I have put 66 bar 20 kV. This is actually a cut and paste mistake. It is, you can think that it's an 11 kV. We have a distribution of 11 kV and our transformers are comparatively larger in size. It is not 10 kVA or 20 kVA, but these are larger transformers, and one transformer probably is supplying to several consumers, for example, 100 houses, 200 houses, and that much. And the line length is long for public distribution and short for industrial distribution. Now, under this circumstance, what we are doing, the biggest mistake is we are trying to make an earth grid for this transformer as per IEEE 80. We wanted to make an earth grid, gravel resistivity test, touch voltage, step voltage test, or all the test as per, or all the safety measures as per IEEE 80. We wanted to implement for this small transformer. This is a misinterpretation of our system. If you go as per the American standard, you should understand what exactly they are doing, and we should do it. Don't try to apply the American system for our 11 kV transformer. For 11 kV transformer, these are actually not applicable. The IS 3043, clause number 27.2.4, it very clearly has written, in the case of an EHT substation where there is possibility of ground potential attaining very high values of the order of 5 kV and above, in the event of an earth fault, the earth grid design should be based on the tolerable limit of potential gradient in the substation area and the step and touch potential due to fault condition. So basically, this clause says you must do these touch and step voltage safety measures for EHT substations, means above 33 kV. However, the definition of EHT itself is nowadays a little bit conflict. This clause in IS 3043 is existing for more than 25 years. So I took the definition from the IA rule 1956 because this clause is originally before 2010. So according to the definition at that point of time, 33 kV or not 33 actually, more than 33 is an EHT supply. So touch and step potential reduction measures with respect to the IEEE 80 standard is necessary for EHT substations. This is the simple definition. But for modern industrial and commercial buildings with high voltage or extra high voltage supplies, the complete earthing arrangement can be made possible by a very, very modern method, which is called as global earthing system. Global earthing system, the name looks very fancy, but the advantage of this global earthing system is literally there is no touch voltage exist. So I was testing 2 weeks back, I was testing an installation where they have a 220 kV substation, 220/22 kV, and the 22 kV distribution goes to 8 buildings, and each of these buildings, they have 22 kV/400 volt transformers, because this is a data center, so they have a lot of load, I think about 75 megawatt. The touch voltage which we got, the result of the test is less than 2.1 volt in comparison to the tolerable limit of more than probably 600 or 800 volt. That is the limit. But the actual touch voltage was less than 2.1 volt. A global earthing system is an earthing system which is achieved by interconnecting every exposed and extraneous conductive parts in a building. You make a maximum interconnection. As a result, the touch and step voltages do not exist in the building. Similarly, for the same system, if you go for a mesh bonding network, BN network for electronic apparatus, you will achieve a very high degree of safety for your electronic device. So this is the most modern method which is recommended in the IEC standard. Of course, in this kind of a system, there is no earth pit, there is no vertical earth electrodes in the soil. Of course, sometime it is required, but not like 200 numbers, 500 numbers, and all, probably 3, 4, 5 numbers. But the biggest advantage of this system is touch voltage is nearly negligible, and your devices, you will get a very, very high degree of safety. This is recommended in IEC standard IEC 61936. An equivalent Indian standard is under preparation by the ETD 19. Probably within a few months, this standard also will be published. If we get it, probably the concepts start changing. With respect to utility companies, the utility, one of the responsibility of the utility is the first responsibility, which I told you, in case of any problem, any fault on the consumer premise, the incoming fuse must disconnect within the time specified in the standard. Number two, the utility also should take care that the fault on the high voltage system, on the left hand side, what I am showing is duration of earth fault in the high voltage system. Of course, 11 kV transformer, in case of a fault on the 11 kV side, at the 230 volt side, a temporary over voltage will appear. And that temporary over voltage, there are two conditions: the disconnection time less than 5 seconds and greater than or equal to greater than 5 seconds or less than or equal to 5 seconds. There are two disconnection times. Greater than 5 seconds is an indication that the high voltage 11 kV side of the high voltage feeder or the high voltage transformer, it is an unearthed system. Less than or equal to 5 seconds is applicable for a earthed system. Imagine an earthed system, 11 kV side is going to disconnect in case of a fault at a time lesser than 5 seconds, lesser than or equal to 5 seconds. Under that condition, the maximum voltage, the maximum over voltage which is allowed inside a consumer premise must be limited to less than 1200 volt, or the maximum must be limited to 1200 volt. More than 1200 volt, the utility shall not allow inside a consumer premise, because consumers are having devices which cannot withstand such voltages. So it is the full responsibility of the consumer, of the energy supplier. But I had a lot of discussion with electricity supply companies, but this particular requirement, anyway, it is not there on the regulation, but it is there on the code of practices. But the awareness is quite less. The touch voltages, the IEC way, IEC 61936, it is explaining the touch voltage, permissible touch voltage. You can also find this chart table in the IS 732. The permissible touch voltage followed in IEC and IEEE, you will be able to see a little bit difference, but practically both are almost the same. What IEC recommends is a fault of less than or equal to 65 volt, or within 10 seconds the fault must be reduced, the touch voltage must be reduced to 65 volt. Why I am showing this picture is this is a mandatory electrical safety requirement, and sometimes the utilities are ensuring it. It is not the consumer who has to ensure it, it is the utility. I will explain how this is done by the utility. Now, disconnection time. Almost every developed nation, what I am showing in the picture is you have the distribution transformer, you have a consumer premise which is having a meter, then inside the consumer premise you have the distribution, and finally the fixed equipment and the portable devices connected to this particular installation. Now, the disconnection time during a fault on the distribution is the responsibility of the distribution company. Most of the nations have made regulations and fixed this particular disconnection time. Example, in a TN system, maximum is 60 minutes. Within 1 hour, in case of any fault, the HT supply must be disconnected, and this kind of regulations are made and they follow. Whereas in India, unfortunately, this is not very much followed. As a result, a lot of accidents are happening. So please understand that in case of fault, you cannot leave the circuit under faulty condition for a longer time. The maximum allowed times are in the final circuit, in case of TN system 0.4 second, and in case of TT system 0.2 second. At the main distribution circuits inside the consumer premise after the meter, it can be in case of TN system up to 5 seconds, or in case of TT it is less than 1 second. These voltage, these disconnection times are applicable for up to 230 volt. But now, when we talk about electricity supply companies, a big discussion starts happening. They say our supply is not 230, it is 240. Yes, of course, if your supply is 240, then the disconnection time is even smaller. In case of a 240 volt supply, the TN system disconnection time is 0.2 second and TT is 0.07 second. That, defining the voltage is having a little bit risk here. Similarly, another important subject which is under the scope of the energy supplier, which is most of the time creating trouble in the consumer premise, is called as installation category or over voltage category. What does it mean is, you have the transformer, you have the meters, then you have the fixed part of the installation, then you have the connected apparatus. Now, every electrical apparatus at the mains incoming must be of category 4, means a 230 volt device must withstand a minimum 6 kV voltage impulse. At the fixed part of the installation, category 3 means a 230 volt device must withstand minimum 4 kV voltage impulse or 4000 volt impulse. Connected device such as apparatus which we use at our houses, these are category 2. A 230 volt device must withstand 2.5 kV. This is also an indication that this voltage, say for example 2.5 kV, this is the maximum voltage with which a portable device at our house can withstand. But imagine, due to a fault on the high voltage side of the transformer, if more than 2.5 kV comes into our house, then of course our TV, fridge, and all these electrical apparatus will fail. And as a result, a lot of cases are recorded where fire accidents happened. Fire accidents due to a high voltage fault at the transformer. Similarly, the category 1 devices are also there, means a 230 volt device which can withstand only 1500 volt AC and voltage impulse. And these devices are actually not suitable for direct connection to a public low voltage supply, because in a public low voltage supply, during a high voltage fault, the energy supplier is free to go to a temporary over voltage up to 1200 volt plus the operating voltage 230 volt. So the actual voltage between earth and a phase conductor, it can be anything 1430 volt up to 5 seconds. This is allowed in the standard. And the utility is not supposed to send more than this voltage into a consumer premise. So this is very much there. So category 1 device, we are not supposed to connect directly to a public LV supply, but this is the, these requirements are there in the standard, but only few of the consumers follow it. Category 1 device, one of the example is some of the variable frequency drives, some of the power supplies, they are category 1. Technically, we are not supposed to connect it to the energy suppliers direct supply. We are supposed to have an electrical separation in between. And this, what I wanted to explain to you is electrical equipment are classified into class 1. Class 1 means an equipment, example, a motor. In case of an insulation failure inside the motor, its body becomes exposed to a voltage, and if somebody touches this particular body, he will get a shock. And what the manufacturer says, the manufacturer's responsibility is he has to make an earth terminal of that particular equipment, and he has to put either the number 5019 or letters P or color combination green and yellow. This is the symbol of protective earthing. And now, most important, what the consumer must do is, once when you buy a class 1 equipment and once when you connect it to your building or to your installation, you must do protective earthing. What is protective earthing is, connect this terminal. This terminal means the terminal of that class 1 equipment to the protective equipotential bonding system of the installation. Then people will be trying to find out what exactly is this protective equipotential bonding. Let me skip these two parts. You can find this picture in IS 3043. I think picture number 14 or 15. I don't remember the number exactly. So it shows, in the IS standard, it's a black and white picture. I put as a color. So you can see the building, and this the green line, which is running all around item number 1. This is the protective equipotential bonding. Number 1, the green ring, equipotential bonding conductor. The old name is equipotential bonding conductor, but the new names are, it is either an MET, main earthing terminal, or a protective earth conductor. Now, interestingly, you see in the IS standard 1965 onwards, this is written, in case of small domestic installation, one is taken from the neutral link. Sorry, there is some small mistake. One is taken from the neutral link. That means it's a TNCS system. So basically, what this picture says is, M stands for exposed conductive parts, means major three-phase electrical apparatus. These three-phase electrical apparatuses are connected or protective earthed to the equipotential bonding system of your building by duplicate connection. Number 2, protective conductor in duplicate. This is actually double earthing. What double earthing means is, you have a protective equipotential bonding in your building, and you are buying a new motor. The motor earth terminal must be connected to the equipotential bonding system with the 2 connections for redundancy. This is the double earthing. It has nothing to do with the 2 earth pits in soil. Every building must have a protective equipotential bonding, which is written everywhere in the standards and regulations. Protective equipotential bonding is created by interconnecting various exposed and extraneous conductive parts in the building. I often explain this picture, so people know this picture very well. You have an MET, means a big bus bar, which is the zero reference of the whole building, and all the metallic parts, exposed and extraneous parts, must be connected to this particular bus bar. And the bus bar is connected to an earth electrode in case of a TT system, and to the neutral of the system, neutral of the source in case of a TN system. And this is whole thing is together called as protective equipotential bonding. So protective earthing means you should connect your motor, or you should connect your class 1 apparatus to your protective equipotential bonding. That is called as protective earthing. It has nothing to do with the earth electrode in soil. IS 732, the picture number 68, I believe, you can see this kind of a picture. What does it mean is, you have a building. The rebar, this green at the center is nothing but the rebar, an indication of the rebar. Then you have an MET, and all the incoming services such as power supply, telephone line, cable TV, gas and water, all these incoming services, metallic services, are connected to the equipotential bonding system. This is very much necessary. And this bonding system has got 3 purposes. Purpose number 1 is reducing the shock voltage of simultaneously accessible metallic parts inside the building. Number 2, in case of any lightning over voltage coming through this particular line, the over voltages are limited to a minimum. And number 3, which is very important, whenever there is a fault on the high voltage side of the distribution transformer, and if the network is a TNCS or a TNS network, the shock voltage inside the consumer premise due to the high voltage fault is also minimized because of this protective equipotential bonding. So it's very important. In some countries, this kind of protective equipotential bonding, it is ensured by the energy supplier. So while checking, they also ensure that the interconnection, the equipotential bonding is made properly. Whereas in our case, the regulation says, regulation 33 says you should check the insulation resistance, and every 5 years you should check, but that basic itself is missing. The selection of conductors and the protective device at the final circuit, very, very important. Lot of places, recently, about a week back, I was discussing with one of the customer. Then I asked, okay, on what basis you are selecting the wire and the MCB? Then they told, if we have a chiller of, let us say, which require 32 amps current, then we put 63 amps MCB, and we put a wire of wire which can handle maybe 35 amps of current. So which is absolutely not the correct way. You should follow this the calculation in the standard. You should select the wires based on the withstanding capacities, and it is not an easy task with which you can calculate something by your fingers and do it. Not possible. You have to be technically, you should understand the subject, and you should do the selection properly. Also, people always think that an MCB, in case of any problem, MCB will trip, which is also not correct. An MCB, any type of MCB, B, C, or D, if the current is 1.13 times of the nominal rated current, 10 amps, say for example, I put 10 amps is the current of the MCB, up to 11.3 amps, the MCB need not have to trip. Up to 1.45 times its rated current, MCBs of less than or equal to 63 amps, it can take up to 1 hour to trip. Higher than 63 amps, less than, it can take up to 2 hours to trip. This also means your wiring must be able to withstand a higher current up to this duration. Example, the wiring must withstand 1.45 times the current for 1 hour for circuits lesser than or equal to 63 amps, and for circuits greater than 63 amps, minimum 2 hours. The next disconnection part of a BIC and a D type MCB is a overcurrent of 2.55 times, up to 32 amps. An MCB of less than or equal to 32 amps, it can take anything between 1 second to 60 seconds. Higher than 32 amps, it can take 1 second to 120 seconds, 2 minutes to trip. And in case of, quick disconnection within 0.1 second, then B-type MCB should have a minimum 5 times its rated current during the fault or the overcurrent. C-type 10 times, D-type 20 times. So based on this, 5 times, 10 times, and 20 times, the fault loop impedances will come into picture. Because in a TN system, we are supposed to use MCB as the primary earth fault protective device. Of course, the RCDs are additional protective device. So this one is actually related to the disconnection time. But don't think that an MCB, by putting an MCB in case of any problem, immediately it will trip. No, not like that. It takes its own time to trip. Similarly, voltage drop. Voltage drop, the maximum voltage drop inside a consumer premise is set by the standard. A lot of engineers try to interpret as, you look a lighting load in case of a public electricity supply, lighting load only 3%. Even if it is 4, 5, 6%, nothing happens. This is what people think. In case of a low voltage supply from our own transformer, up to 6% voltage drop is allowed in case of lighting load. But people sometimes interpret as, even if the 6% is instead of 6, if it is even 7, 8%, my lights are able to work, because my light is able to work with 230 plus or minus 20%, for example. So as a result, people try to not see these requirements seriously. As a result, what happens is, these calculations are also very well included in the IS 732 standard. I am showing you a picture, figure 98 from IS 732, how to select the wire for a 3-phase system. Of course, say for example, 2.5 square mm wire, 16 amps, you can use up to 70 meters, but it is for 3-phase application. For single-phase application, 2.5 square mm, 2.5 square mm wire. The maximum cable length is 70. 16 amps you can use for 3-phase, whereas for single phase you can maximum use it for 35 meters. All these, why I'm showing this is, all these calculations must be followed properly. I skip this one. The cross-sectional area of neutral conductor, which is also equally important. But often people think that neutral is not important. So if the phase is 6 square mm, let us use 2.5 square mm for neutral conductor and 2.5 square mm for earth conductor, which is actually wrong. The neutral, why I said made this statement is about 6 months back, I saw this in a hospital, especially the wiring which is going to a very critical place. The phase conductor was 10 square mm copper and the neutral conductor was about 4 square mm, and all the equipment are single phase. Of course, the neutral conductor shall have the same size of the phase conductor for single phase circuits and multi-phase circuits, where the cross-sectional area, if the size of the phase and phase is up to 16 square mm copper, then the neutral also must be 16 square mm. More than that, we can, there are some excuses. So you also should consider harmonics in case of in case of the neutral conductor. Single phase, single core cable with armored with steel wire and tapes are not to be used in AC circuit. Conductors of AC circuit installed in ferromagnetic enclosure shall be arranged so that the conductors of all the phases and the neutral conductor and the appropriate protective conductor of each circuit are contained within the same enclosure. Of course, these are the additional requirements. Now, while selecting the MCB, the steps which you are supposed to follow is number one, estimation of the connected load in kilowatt. And first you should find out what is the current requirement, also the starting current. Then selection of the type of the MCB, because the first one is the load requirement. Then we should select the protective device. Third, we should select the wire, including its length, voltage drop, condition of installation, and the derating factors, and so on. Then you also should consider estimation of earth fault and short circuit loop impedance and the prospective short circuit currents, because your device is supposed to trip in case of a trouble. Applying diversity factor on the final dBs and selection and of the incoming circuit breaker of the the rating of the incoming circuit breaker, you can apply the demand factor and you can diversity factor and you can select. This is the step you are supposed to follow. Why I showed this is most of the time oversized devices are used, which is also one of the reasons for non-disconnection of the supply, which is resulting in accidents. Voltage drop. In lot of cases, a higher voltage drop means a higher impedance. So if the standard is saying you must limit the voltage drop to 6% for lighting load, if you have your own transformer, you should not cross that. If you cross, this means that the impedance is higher. It will lead to higher disconnection time because the fault current or the short circuit current is less. The higher disconnection time will come into picture and you are actually compromising safety. Similarly, a higher voltage drop is also an indication, voltage between neutral and earth, a high voltage potential difference between neutral and earth, let us say 8 volt between neutral and earth, is an indication of voltage drop of up to 16 volt in a single phase installation. So if you measure something 8 volt between neutral and earth at one point of an installation, so at that point of the installation, the single phase equipment, it's an indication that the single phase equipment at that location, that particular place is having a voltage drop of up to 16 volt, which is actually, we are going to the limits. We are not supposed to have that much voltage drop. Now, higher voltage drop or higher voltage difference, not a drop, in fact, higher voltage difference is also considered as due to poor earthing. This technique also can be used to find out whether the system is TT or TN. Most often, in case of a TT system with a very unreliable earth electrode or loose contacts, sometimes the earth to neutral, protective conductor to neutral voltage is either unstable or very high voltage. Of course, we are not supposed to follow TT system. As per our regulation, we are supposed to follow TN system. So what I wanted to tell you is voltage drop is also a very good way of finding out the probable causes of problems in the future. Electronic equipment manufacturers such as UPS and lift vendors and all, they say that a higher voltage of neutral to earth, 10 volt between neutral and earth or 8 volt between neutral and earth is the reason for the failure of their equipment, which is actually not correct. And 8 volt between neutral and earth in a lift, of course, in the drive of the lift is an indication that it is a TT system, and in case of any problem, the MCB is not going to trip. That is the way we should interpret it. So, in fact, the neutral to earth voltage of up to 50 volt between neutral and earth in a good system is supposed to not create any problem, because between neutral and earth, we are supposed to have 1 megavolt voltage difference. Somebody is writing, my voice is breaking. I don't know how it is happening. Sorry for that. Now, the voltage drop in foreign countries, how they think about voltage drop is, say, for example, I'm saying our voltage is 230 plus or minus 10%. You just take an example. What they say is, at the transformer, if you put the tapping to the maximum, your voltage output at the transformer is 230 plus 10%. You can make it in order to ensure that the last consumer during the peak hour is able to get 230 minus 10%. The last consumer, you must supply a voltage up to 230 minus 10%, and not more than that. Lesser voltage is a problem to the consumer premise. So the minimum voltage at the consumer premise is 230 minus 10%. So the transformer 230 plus 10%, consumer premise 230 minus 10%. It means a customer who is at X distance, his voltage is actually stable. It may be 230, for example, the first consumer, always his voltage is 230 plus 9%. And probably another customer is always 230 minus 9%. So how we should start reading these requirements are, imagine I have my house, which is probably 200 meters from the transformer. At morning, I get 230 plus 10% voltage, and at the evening, I get 230 minus 10% voltage. This is not accepted. So we should start reading that this plus or minus 10%, we should read in such a way that the transformer secondary side tapping maximum 10%, the end user, the last consumer should get 10% minus. Also, I told you last time, the energy classification, any connected equipment lesser than or equal to 15 watts during a fault or during an overcurrent, or it is not supposed to ignite fire. And 100 watts, of course, it may create under some condition. More than 100 watts is a little bit danger. But now, if you are able to disconnect the supply within 3 seconds, of course, you achieve safety from fire. Less than 5 seconds or maximum 5 seconds and limited to less than 100 watts, probably it is still safer. But exceeding the limits of 5 seconds and 100 watts is always risky. This means that if we analyze the fire accidents, and if it is really from the short circuit, these are some of the techniques which can be used for analyzing the circuit. Now going to the last part of my presentation. We are trying to make a software, because as I said, a magic device cannot bring you a solution. It is really a knowledge. Lot of technical points are there, and it will be very difficult for one engineer to keep everything in the mind and try to follow it, which will be very difficult. So we are trying to make a software which we call as solve safe operation of low voltage electricity. We will be introducing this very soon. We are seriously working. So with this software, we will allow the customers to log in, and they can go through the steps explained in the standards, and they can go through the steps which is there on the software, built in the software, and do your testing as well as investigation. So this is going to come up very soon. You can use this platform as to ensure safety. What we are trying to do is we are trying to make this platform to give some kind of design support with respect to safety related issues, not all the design things of a low voltage electrical system, but only the safety related points. Then we are trying to make trainings out of it, then verification of basic drawings, plus compliance to standards, support during erection, and all these points as a whole we are trying to include in this particular software. Most probably we will be making it or launching it probably within a month. So by this, I would like to stop the presentation. Thank you very much for listening to me. You can also note down my email address and mobile number. In case of any doubts or clarification, please don't hesitate to mail me. My email address is gk@capeindia.net. My mobile number is 99625 222 Actually, 544 I put, that is a mistake. 222 is the correct number. I'm sorry for that. Yeah, let me remove it. So you can note down, and you can don't hesitate to, but most of the time I may not attend the phone calls, but I'm always available in chats or WhatsApp or whatever. You can use it, and we can answer to you. So by this, I would like to stop. Thank you very much, and over to you, Mr. Dominic.
So I just mentioned our Solve software, the website in the chat box. People can follow the Solve software, the update and the services that we are offering in that. And also Gopal Kumar's mail ID and the contact number is mentioned. You may note the information that is there on the chat box. And let me go galleries. Yeah, well, let's move towards taking few questions. It is almost 1 hour, 15 minutes now. So we'll try and see maximum, how much we can cover. I think some of the answer has already been done during this presentation. So I will just pick up Narsingh Rao Pujari asking, how can we protect the LV installation in a hospital or a building against temporary overvoltage?
Yeah, this is actually temporary overvoltage is mostly the reason because of the problem in the transformer. Especially, you can get temporary overvoltage due to various reasons. One of the reason is a neutral loss, a single phase circuit, and in case of a neutral disconnection, of course, you will have a temporary overvoltage. You have to handle it in one way. The next way is in case of any fault on the high voltage side of a transformer, of course, you will have a temporary overvoltage. And here, you must make your system earthing in such a way that you should actually follow the TNS system properly. If you compromise the TNS system and if you go for a TT system, of course, you will have this kind of a problem. If your system is TNS, the temporary overvoltage at your premise is solved. That is why the hospital standards IS 17512 is strictly recommending to go for a TNS system for a hospital. So this is the answer.
Again, as demand always there for your missing link and guide to electrical safety in LV electric installation. So I think you must find a way to get this publications, the book to the participants. There's a lot of demand for this. So I think next webinar, I'm sure he may give you the link to buy this information.
No, so. Actually, Mr. Dominic, what has happened is, the book, when how it started is when the COVID started, I started doing some activities for the electrical inspectorate engineers. Then the demand came in such a way that almost every day it was happening. And during the full lockdown time, about 120 days continuously it happened. And then the chief engineers of some of the electrical inspectorate, they told me to make it as a book. And then I made it, and we published about 10,000 copies free of charge. I have some more copies. And after our last program, I have got at least 25 emails requesting for the book. And I sent it by courier to all of them.
I think Narsingh Rao will get it soon. I think is quite keen to know. I think we'll try and see how best, whether it is in a software, soft copy format or a print format, we'll try to reach it. So let's move into, Raibhan Gaikwad is asking, sir, regulation says 5 years, but EI visiting annually. So which to follow?
Regulation says 5 year for testing. EI's visit is not the requirement of regulation. EI can visit weekly or monthly or annually. That is a different thing. The question is, in a low voltage consumer premise, are you testing every 5 years, especially the insulation resistance? If you are testing and ensuring it's well and good, we should push all the utilities to do that. It can be done by the electrical inspector, need not be done by the electrical inspector, because most of the state government electrical inspectorates, the engineers are limited. They cannot do this. Probably, now the chartered electrical safety engineer should do it. So that is the easy way.
Sir, Masum Raza is asking, how about DG license when applicable in factory or warehouse? I don't know whether we can answer that.
No, about DG license when applicable in factory or actually this is subject of the electrical inspectorate. So now if you look at the regulation, mostly the regulation is talking about the subjects up to the point of commencement of supply. One of the exemption is DG, because imagine the incoming supply is off due to probably the utility company had, the energy supplier had disconnected the supply from the transformer for some maintenance, and sometime a consumer premise, a DG working in the consumer premise can backfeed the supply, which will kill people of the distribution company, those who are working on the line, overhead line. So in order to avoid such accidents, a DG has to be certified by the electrical inspector. Mostly the purpose is this backfeeding must be stopped. You should actually get in touch with the electrical inspectorate.
The chat saying the electrical inspectorate is hardly there is a support from them. It's not worth to try and effort to get those details. So that's how the chat, somebody frustrated, response to that. Anyway, let's move on. Tanmay is asking, sir, do you provide design support for industrial or industrial project design? Did you take it up?
What was the question?
Do you provide design support for industrial projects?
Oh, no. Not the electrical system complete. We support only for the safety part. That means somebody is designing it and that particular drawings are given to us. We will check only whether the compliance to the standards regulation with respect to safety is met or not. Sometime or most of the time, some improvements are necessary. That advice we give.
Okay. How to avoid backfeeding from our side or DG vendor side?
You are supposed to make actually a 4-pole isolator. For example, in IS 732, there is a picture. I think the class number is 4.45, 4.44. You can find out that particular class and you can find out from that. The explanations are given there.
Okay, not much question this time. Gopakumar, maybe because evening people want to rush back home and I think it's almost 6:20, so we have done with the questions. So anyway, those who wish to put more questions, you're always welcome. You can send the mail either to Mr. Gopakumar or my mail ID, which is given there. And very soon, maybe end of this month, we will come with part 4 webinar on electrical safety. And we look forward to see you. So please feel free to keep sending your queries to us. And the recording of this whole presentation will be shared to all the participants and the people who registered, but unfortunately they couldn't attend. So we will share the YouTube link to all of you, which you can again, at your convenience, you can go through that. Again, you can send your queries. So it's wonderful to have you all in this webinar, the part 3, and we enjoyed having your presence here. We look forward to see you again, and we'll be announcing the next webinar shortly, and you will be we'll be communicate to you on email. So have a wonderful weekend. Stay safe and practice good safety system in your building and your home. Thank you very much. Gopakumar, you want to say a few words?
Yes, I would like to add one point. Somebody asked about the electrical inspectorate testing by electrical inspector. Don't expect the electrical inspector to come and test each and every installation, because the inspectorate, the number of people are quite less. And the number of, in comparison, the number of installations where you have DGs are in thousands. So you cannot expect them to come and inspect, especially the regulation 30 insulation resistance test. Probably they may not be able to do it. But there is a solution already. The regulation 5A, which is talking about the chartered electrical safety engineer, probably chartered electrical safety engineer may be able to do it. Now, the second point which I wanted to tell is, if you wanted to have this particular, the last week, our program, we have made as a report with the presentation and other things, and actually included in the social media. You can actually download all the information, including videos you can see in the social media. And if you want the book, please send a mail with your address to my mail ID or by a WhatsApp. So by this, thank you very much. Thanks for all of you.
Thank you very much. We're always there to help you, support you with whatever information. And as you said, if somebody wants the missing link book, please send him a mail directly or send a chat on his WhatsApp. So we will get back to you. And those who missed the part 1, part 2, 3, we will definitely share you those links, and it's there available in the YouTube. I think we have more than 1,500 views on that. Very interesting and well appreciated by most of us who's attending. And this is a basic fundamental that we are covering. So we look forward to see you again. Have a wonderful day and good weekend. Thank you very much. God bless you all.
Thank you. Thank you very much, Mr. Dominic. Thank you. See you.
Right.
See you.